everyone. I'm Aman Kumar Sharma from NITR, and today we are going to discuss about nodal analysis. So let's get started. So let's consider the circuit first. So in a nodal analysis method, what we do is first you need to choose a reference node. Let the reference node be B, and now reference node means the node having a zero potential. Basically what we do is we earth it, and now now we are going to apply KCL at node A. Okay, if there are other nodes, you can also apply KCL at that node in order to determine the voltage at A. Now how we are going to do that? So let's see. By applying Kirchhoff's current law at A, so the current which is approaching the node will take it as negative, and the current which is moving away from the node will take it as positive. So we are having this expression as I1 minus I1 plus I3 minus of I2, and this is equals to 0. And so I1 is equals to, we know that voltage at A minus this one, it is E1 by R1, and then I3 is equals to voltage of A minus voltage of B by R3, and voltage of B is 0, so we will do as VA minus of 0 by I3. Then likewise I2 is VA minus E2 by this R2, VA minus E2 by R2 is equal to 0. So this is how you determine a voltage at any node with the help of nodal analysis by choosing a reference node. Now we'll do one example to have a better clarity. So now consider this problem. So we need to find current in this 1 ohms resistor. So now we are going to use nodal analysis to solve this problem. So let this node 3 be a reference node. Okay, I'm taking this as a reference node, so the potential of this node 3 will be 0. And so now we'll apply KCL at node 1. So V1 minus 12 by 2 plus V1 by 5, V1 minus 0 by 5, it is in this branch, and then V1 minus V2 by 1, that is here along this branch. Okay, if you simplify this, you'll get like somewhere like 17 V1 minus 10 V2 equals to 60. This is our equation 1. Okay, then again you apply KCL at node 2. It is here. Then you will have V2 minus 0 by 4 omega at this one, V2 minus 0, and then V2 minus V1 by 1 omega, and then again along this branch V2 minus 24 by 3 is V2 minus 24 by 3 equals to 0. If you simplify this expression, you will get minus 12 V1 plus 19 V2 equals to 96, and this is equation number 2. Now if you solve this two, I've already solved it. So on solving these two equations 1 and 2, you will get V1 equals to 10.35 volts and V2 equals to 11.6 volts. So now since you have now value of V1 and V2, that is voltage at node 1 and node 2, you can easily find current in this branch, that is 1 ohms branch. So if this current be I0, then value of phi naught equals to v2 minus of v1 by 1 omega, that is equals to 11.6 minus 10.35 volts by 1 omega, and that is equals 1.25 ampere. And this current is directed from 1 to 2, node 1 to node 2, because voltage of node 2, sorry, from node 2, it is the current direction of current is from node 2 to node 1, because voltage of 2 is more than voltage of node 1. Okay, so now we have solved this problem, and so try to apply this nodal analysis with some other circuit problems, and thank you for watching the video.